So for item 13, we're looking at the inclusive or and the exclusive or, the difference between them, right? Should have just written, yeah, this is the exclusive or. So the difference between them is that the inclusive or is true when both of them are true, but the exclusive or is false when both of them are true. For the exclusive or, it is only true when one is true and the other is false, and vice versa. So let us set up this truth table that is true, true, false, false, true, false, true, false. Now let's look at the exclusive or, right? So when both of them are true, this is actually false. When we have true and false, we have true, false and true, we have true, and lastly, false or false, we have false. So this is the truth table for the exclusive or. Now let's build up these auxiliary truth tables so that we can look at item 2, because we want to show that the truth table for the exclusive or is equal to the truth table of A or B and not A and B. So to do that, we'll just kind of set it up step by step so we don't make any mistakes. So for the conjunction of A and B, we have that this is true, false, false, false. Now we want to negate this conjunction, right? So we're just going to take the opposite of the fourth column. So we're going to go where it's true, it's going to be false, and then where it's false, it's going to be true. And lastly, when we want to do just A or B, so it's almost the same truth table as A, exclusive or B, but the only difference is that for the first line where both of them are true, this is true. So now we're just going to copy all the other values for the exclusive A or B, and then that is false, right? Lastly, we want to do the conjunction between the fifth column and the sixth column. So we're going to do not A and B and A or B. So let's do that conjunction. False and true is false, true and true is true, true and true is true, and true and false is false. So if we compare these truth tables, right, the one for the exclusive A or B, and the one for item 2, we can see that these truth tables are the same. Therefore, these statements are logically equivalent. So let's just put a check that we did both of these items. Okay, now let's look at item B. So for item B, we're looking at NAND and NOR, which in circuits, NAND means not A and B, and NOR means not A or B. So let's set up these truth tables. So we have here, this is, oops, I wrote A, I should have written true, right? So this is true, true, false, false, and then true, false, true, false. So we're just setting up these auxiliary truth tables, statements rather, as we've made before, so that we can build up compound statements without making any mistakes. So A or B, the disjunction is true, false, false, false. Now let's do the conjunction. So that is, oops, I made a mistake. I wrote the conjunction when I should have written the disjunction. So that is true, 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 and false. Now let's do the conjunction. So we did the disjunction, we'll do the conjunction. This is true, false, false, and false. So now let's do NAND. So this is NAND, and this is NOR. So all we're doing is we are negating A and B. So let's negate that column. So wherever we have true, we're going to put false. And wherever we have false here in the fourth column, we're going to put true. So false, true, 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 right? We just negated this column over here. And now let's do NOR. So for nor, we are negating the third column. So we're negating the disjunction of A with B. So wherever we have true, we're going to put false. So that is false, false. And lastly, we have false. So the negation is true. All right, so we did item 1. We can put a little check mark there. Now let's do item 2. So we have to show that A NAND B or A NOR B is equivalent to A NAND B. So what we're doing here is we're taking the disjunction of the 5th and 6th column. So let's do the disjunction, the 5th or the 6th column. So here we have false or false is false. True or false is true. True or false is true. And true or true is true. So what we're saying is, hey, let's compare this one to, so we compared this one over here, right? Which is this column. And then we want to compare it to the NAND. So we want to compare it to this column over here in blue. So let's see, we have false, false, true, 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 and true, true. So these are in fact the same. So we have proved that. So let's put a little check mark. And then lastly, we want to prove that the conjunction of NAND and NOR, right? We want to prove that this conjunction over here. So let's first do that conjunction. So what we're doing is we're doing the conjunction of the 5th column with the 6th column. So for this one, we have, let's see, false and false is false, true and false is false, true and false is false, and then true and true is true. And now we want to show that it is equivalent to A NOR B. So to A NOR B, so we're comparing this column over here with this column. So let's compare it. False, 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 and true, true. So they are in fact equivalent. So we have proved that. And that is it for item 13. So let me just zoom out so you guys can see. Yeah, and that is what we want to prove.